Hello, good morning students. In previous class we have studied the basic working principle of induction motor. Basically it consists two parts. One is referred as stator, one is referred as rotor. Between these two there is a presence of gap. It is known as air gap. So its working principle, it is analogy to transformer. Transformer is also works on mutual induction. This induction motor is also works on mutual induction principle as per the Faraday's laws of electromagnetic induction. Stator is analogous to primary winding. Rotor is analogous to secondary winding. Mutual induced EMF is developed in secondary winding, that is in rotor. Supply we are giving to stator, that is of primary winding of transformer. This way you have to remember, it is already we have discussed. Today we have to discuss the problems. So one important thing, we have to follow the general steps or points we have to remember and write on one side before going to the solutions of problems. So these are the some important steps are: number one, NS. NS is known as synchronous speed. Synchronous speed is given by 120 F by P, where F is supply frequency, or it is also referred as stator frequency. P is number of poles. So the synchronous speed is expressed in revolutions per minute, RPM. Next, number two, actual speed of motor is considered as N RPM. So it is also referred as motor speed or rotor speed. Actually we observe the rotation of rotor, so it is referred as actual speed of motor. The rotating magnetic field, it is imaginary part, it is not possible to observe, that is synchronous speed. Then slip is denoting by S. It is equal to difference of speed. Slip speed is called Ns minus N, that is synchronous speed of rotating magnetic field and actual speed of the motor. It is called slip speed. So how you are going to calculate slip? Slip equal to difference Ns minus N divided by Ns into 100. If you are multiplying 100, you are going to get percentage slip. You are not multiplying 100, that is fractional value of slip. After knowing the slip, so we are knowing in transformer primary frequency and secondary frequency both are same, but in case of induction motor, when the motor is at rest, supply frequency equal to rotor frequency. Primary winding of transformer, it is stator of induction motor. Hence supply frequency equal to secondary rotor induced EMF frequency, that is rotor side is taken as F dash. When the motor is at rest, both frequencies are same, that is stator frequency is equal to rotor frequency. At this condition is referred as transformer behavior. When the motor starts the rotating, the frequency of rotor circuit goes on decreasing. So when the motor is running, F dash, that is rotor induced EMF frequency, is given by slip times of supply frequency, S into F, one of the important relation. So if the rotor induced EMF frequency is available, supply frequency is available, then it is possible to calculate slip equal to F dash by F. So after knowing the slip from above two expressions, then it is also possible to calculate the speed of motor or rotor speed, N equal to Ns into 1 minus S. Ns, it is the synchronous speed of rotating magnetic field, and S is fractional value of slip. That means less than 1. We don't take percentage of slip. We have to consider here fractional value of slip. Be careful. Then we have to go for continuation of problems. In previous class we have seen 2 to 3 problems. Next, continuation of that. A 3-phase 6-pole 60 Hz induction motor has a frequency of rotor current at full load of 1.8 Hz. Find the synchronous speed and slip at the full load speed. So you write down given data one side. What are the given things? Number of poles are given, P equal to 6. Then supply frequency is given. Supply means stator frequency or supply frequency, F equal to 50 Hz. Rotor induced EMF or rotor induced current frequency is given, F dash equal to 1.8 Hz. So number 1, you go for calculation of synchronous speed as per question asked. So synchronous speed ns equal to 120 F by P. You substitute the values. Ns we are going to get as 1200 RPM. So we are knowing second one, F dash rotor induced current frequency is given. It is very less, 1.8 Hz, and supply frequency is also given, F equal to 60 Hz. Then it is possible to go for slip equal to F dash by F. So it may be expressed as the fractional value of 0.03 or in the percentage. Better you write both, 0.03 or 3%. Next problem, the frequency of the EMF in the stator of a 4-pole induction motor is 50 Hz and the rotor is 1.5 Hz. What is the slip and at what speed is the motor running? It is the question asked. These all problems have been asked in PTU question paper. So once again you write down the given data. Supply frequency is given, F equal to 50 Hz. Rotor induced EMF frequency is given, F dash equal to 1.5 Hz. Then what is the speed of rotor? What is the speed of motor? N equal to how much? Similarly, go per step. Number of poles is given, supply frequency is available. Go for step number 1, synchronous speed, Ns equal to 120 F by P. Substitute F equal to 50, poles equal to 4, Ns equal to 1500 RPM. Then number 2, you go for slip. Sir, slip as in the problem I shown. Number 3, you go for slip equal to F dash by F. It may be 0.03 or 3%. Then after calculation of slip, go for rotor speed. It is also called motor speed. Motor speed N equal to Ns into 1 minus S, sir. S is once again fractional value of slip. You substitute the value N 1455 RPM. So one of strategy you remember, N and Ns both are nearer. You observe, you are having the answer Ns equal to 1500, N should be nearer 1455. Ns is always greater than N. You remember in the point. If N equal to 970, Ns equal to 1000 RPM. Sir, it is very nearer value. If you are getting more difference, then your problem is wrong. You try to understand. Now in this case, Ns equal to 1500 RPM. N may be nearer 1490, 1480, 1455 RPM. Go for next problem. In this problem also number of poles is given 8, sir. Supply frequency is given 50 Hz. Rotor EMF frequency, that is F dash. F dash is given 1.5 Hz. Then F dash is given, F is given. We are knowing the relation rotor induced EMF frequency F dash equal to slip times supply frequency. From this expression, it is possible to calculate slip equal to F dash by F. Then S equal to, you are getting 0.03 or 3%. Supply frequency is available, number of poles is also available. Go for calculation of synchronous speed. Synchronous speed equal to ns equal to 120 f by p, 120 into 50 divided by 4. Given problem consists 8 poles. You write here 8 poles. I have written 4. So you replace 4 by 8. Hence we are getting ns as 750 rpm. After knowing the synchronous speed, go for actual speed. Actual speed of motor n equal to ns into 1 minus s, sir. ns is 750 rpm. Slip, fractional value of slip is 0.03. So n we are getting nearly 720 rpm. All these problems are important. You understand. After that you take the problem, go on solving. So now you can see there one of question paper problem. It is asked for VTU question paper for 6 marks. Many of problems have same. So a 3-phase 4 poles 400 volts 50 Hertz induction motor runs with a slip of 4%. Find the rotor speed and frequency. So given data you write down all of you one side. Number of poles is given, p equal to 4. Stator frequency is given, f equal to 50 Hertz. Slip value is given, sir, 0.04 or 4%. 4% is given. So you can write fractional value, it is 0.04. Be careful. So number 1, make the calculation of synchronous speed. ns equal to 120 f by p. F is 50 Hertz. Number of poles are 4. Then we are getting as 1500 rpm. Number 2, after that go for rotor speed. Rotor speed equal to n, that is actual motor speed. N equal to ns into 1 minus s. From previous problems we have been learnt. Same formula you can apply. 1500 1 minus 0.04. Slip value should be fractional value. Try to remember 1440 rpm. Then he asked rotor induced EMF frequency. You use the formula f dash. F dash equal to s times of f. F is supply frequency. Again s is fractional value 0.04 into 50. We are getting the answer as 2 Hertz. It is one of the important problem. Same problem has been asked number of times in VTU question paper. A 3-phase 6-pole 50 Hertz induction motor has a slip of 1% at no load and 3% at full load. Determine synchronous speed, no load speed, full load speed, frequency of rotor current at standstill, frequency of rotor current at full load. Same problem is asked number of times in VTU question paper and in our BLD university also. It is asked for number of times in internal test. Very good problem. It means very good problem. So here we have to understand only one relation, sir. N equal to what you are going to write? Ns into 1 minus s. Correct? Here this relation we can use at particular value of slip. At no load, when the motor is not loaded, it is called no load condition. When the motor is loaded, full load, it is called full load condition. Sir, as the load condition, it can change the speed of the motor. Motor is not loaded means speed is high. If motor rating is 1500, it is called no load speed. When the motor is full loaded means full load current of 4 ampere. Motor is loaded for full load current. Slip speed decreases. Speed decreases from 1500 to 1440 or 1450. Now slip value also changes, corresponding slip value changes, load changes, speed changes, slip changes. This point you have to keep in the mind, all of you. Once again, load changes, speed changes, slip changes. So now you understand the problem. This equation we can use for different load conditions, that's all. Number of poles is given 6, supply frequency is given 50 Hz, slip at no load, I can write S naught. Slip at no load S naught is 1% or 0.01 fractional value. Similarly, slip at full load SF 3% or in fractional value 0.03. You write down all data, understand step by step. Number 1, synchronous speed ns equal to, as usual, 120 f by p. You substitute value, we are going to get 1000 rpm. Step number 2, no load speed, no load slip you take. You write the expression, sir, n equal to ns into 1 minus s, that equation only modified. Slip at no load n naught or n0 equal to ns into 1 minus s0. Substitute ns equal to 1000 rpm. Slip at no load is 1%, sir, 0.01. So we are getting 990 rpm. Understand? Please understand. Then similarly we can go for full load speed nf. nf equal to sf changes. nf equal to ns into 1 minus sf. ns remains same, 1000 rpm, 1 minus 0.03 sf value, 3% is given. Fractional value of slip is 0.03, sir, 970 rpm. Number 4, at standstill of motor, means motor is at rest condition. To understand this concept, motor is not running, but stator is given by supply. EMF is induced in rotor. It just behaves like a transformer. Sir, transformer, primary side frequency, secondary side frequency, both are equal. That condition we have to apply. F dash equal to F. Getting the idea, all of you? F dash equal to F. Stator frequency equal to rotor frequency. It becomes 50 Hz. Or another concept is also there. You can apply F dash equal to S times F. When n is 0, slip maximum. When n is 0, actual speed of motor is 0, slip becomes 1. So again we are getting F dash equal to S is 1, F dash equal to F. Getting the idea? Then go for last condition. At full load condition, F dash equal to SF. So full load slip is 0.03, supply frequency is 50 Hz. So we are getting 1.5 Hz. So all of you go through all problems, then practice each one. 3 to 4 types problems are there. Out of these types of problems, one problem may be asked in examination or it may be in IA test. Try to understand. This covers induction motor problems. So tomorrow we can go for different type of rotors. Thank you to one and all.